Hello, I'm Vilgot, and today I am going to show this computer that I and just another engineer have built during the last 3 days. Say hello.
Hi. Channel link in the description. Shameless plug.
Yeah. So his channel will be linked in the description. He also has a video on this computer. So this is the Javelin, which is a combination of our names. Yeah.
Alright, so for the RAM here we have 32 bytes of AND RAM, or AND memory for the RAM. So it doesn't flash when we put it down, but it does like to bug out with the rest of the things that do flash. But there we are, we have a multiplexer for deciding what we actually select, and then main bus right there, and then our enable read and write. Then over here we have the registers, which is the same type of memory, just, registers, so we actually feed all the data through here into the ALU and all the other things that deal with that. And then over here we have the actual instruction registers, which are going to be storing the instructions. So we have A right here, B right here. A would be for storing, say, like the actual instruction, like load A, and then you would have another bit of or another byte from the instruction, which would say what address. So you would have load A 15, which would be load RAM address 15 into register A. Simple enough. Then we have the clock right here, which I designed. Hit the green button, it's got a delay, and then it starts. Hit the red button, it stops. Easy as that. And then that's most of the stuff that I designed, except for the disk reader right here. So you just hit the green button and then start scanning. We put a cartridge in there and it'll actually read the black dots, kind of like a punch card. And then you just hold the red button to stop it halfway through. And then, yeah, that's all that I designed. So Vilga also designed the other half of the computer. So go ahead and
Yeah,
explain that.
so here we have the program counter, which counts what instruction we're on, or address if we have a instruction that actually uses an address, and then loads it up to these registers. Here we have the step counter, which counts every clock cycle with and then goes into this multiplexer. That after that goes into these AND gates that all are combined with this multiplexer from the other instruction register. And with that we can do more complex instructions than without the step counter. We also have a flags register right here, which we basically only use for jump instructions. So jump if carry and 3 others. So these are data manipulation. So the first one is load A, load B, load C, load D, save A, save B, save C, save D. And over here we have movement of registers to A. Here we have the jump instructions, and the one that's shorter than the other ones is the reboot that basically resets everything except the RAM and starts the computer again. And then we have the control word down here, which is connected up to all the inputs and outputs in the computer and things like that, which basically lets the control word talk to the rest of the computer.
All right, so here are all the cartridges slash disks that we prepared to demonstrate the capabilities of the Javelin. So I've designed number 1 and 3, and Vilgot did 2 and 4. So this program number 1 right here is a simple addition, showcase, well, addition and also loading and saving from RAM. So we hit the green button there. So all it does is load A from the first memory address with the first value, then it does add, and then it specifies another memory address, which is where you load it from for the second value, and then that saves automatically to register A, and then we take what's in register A after having been saved from the addition, and we save that to yet another location in the RAM. And this should be 58 plus 41 equals 99, of course, in binary. So that should be done right about now. So if we head over here to the clock and registers, that's done. Hit the green button, and then we watch the registers flick around. There's 58, there's 41, and it adds up to 99. It saves, and it's done already. If we look over here, here we have 58, 41, and then 99 right there. So that works.
So this is the second disk that I designed. It does some subtraction and then shows the saving of flags. So it loads 58 to the A register and then removes 169 from that, which should leave minus 84, and because it's minus 84, we will get a flag that says that it's negative, which we save to a memory address. And we should be done writing this now. Yeah. So now it loads 85, subtracts 169, gets a negative output, saves that, loads that flag into the A register, saves that, and terminates.
That was fast.
Yeah. So here we can see the numbers. This is 85 minus 169 equals probably not this.
The negative numbers. There's probably some fancy way of doing it, but this is just overflow. So
Yeah.
we have no idea what that means.
Yeah, and then we have this bit, and that's on because this flag is on, and so these four flags are connected to the least significant bits.
So this is the next program that I've made. It's disk number 3. So if we load this up, this is a division program. Not exactly proper division, but it still works nonetheless. So as we scan it, I'll explain it. So basically it goes through this one loop constantly until it hits 0, where it adds to a temporary value, or the output value. It adds 1 to that, and then it subtracts the dividend, I think it's called, from the main value. Or if it was x divided by y, it would be subtracting y from x, and then adds 1 to a temporary variable, and it keeps on doing that in a loop until x hits 0, and then the temporary value is your output. So let's see that in action. It's a bit easier to describe when it's actually running. So hit the button there. So first thing it's going to do is load up 0, which seems a bit counterintuitive, but it's just temporary. Then it adds 1 to it. So it adds 1 to that temporary value. Next it loads up 10, which is our x. And it loads up 2, which is our y. It subtracts 2 from 10. We get 8 there. Next it's going to load up our temporary value, which is now at 1, right there. It loads up the constant 1, again, adds it. Now we get 2. After that, it loads up the 8, which is our x, and it loads up 2, subtracts it. Now we're at 6. And after that, it checks to see if the 0 flag has been set. So if the 0 flag has been set, then it'll do the jump. Now here we load up that temporary value again. It was 2, we added 1 to make it 3. So far it's 3. We load up our x, which is 6. Subtract our y, which is 2, so now we get 4 right there. Again, checking for the flags and the jumps. So now it does the jump. Now we have 3 in our temporary value. Now it's added 1, that goes up to 4. When we switch over to the main operation, we get the 4 for our x, we get the 2 for our y, subtract that, and we get 2 for the x. Saves that. And now, again, checking for the flags. Then the final go through, we load up 4, we add 1, we get 5, so that's our answer 5. Now it just has to load up the x and the y again and subtract it. Now it says 0, so now it should terminate. It goes through the jump. Since the flag is set 0, then it hits the terminate, and now the program is done. So if we come over here, right here is our output. So we have 5. So 10 divided by 2 is 5. Now, as the program works, it does destroy the value. But on the input here, you can see it's, or is it 10 divided by 2 right there.
This is the fourth disc, one of the 2 that I made. It calculates the Fibonacci sequence and displays it, or at least it would display it if I would have had enough time to actually make it work. So it takes x and y, adds them together, saves the value that was x to y, and then saves the result to x, and then loops back to the beginning and checks if we got an overflow. And if we got an overflow, we abort the program. So it should be done reading very soon. So now we will see it load up 1 and then add 1 to 1. So we get 2. And after that we will add 1 to 2, and then we will get 3, and so on, until we get an overflow. So now it's 3. We load up a 2 in the B register, add that, so we get 5. And after that we'll get 8, 13, 21, and so on. So that's the Javelin that we've built. Thanks for watching. Go check out Justin Engineer's channel in the description. He's building a computer.
Yeah, so I'm building the turbo snail because it's supposed to be fast, but of course all computers in Scrap Mechanic are pretty darn slow. So turbo snail, I'm documenting all of my construction except for, of course, all the tedious wiring and the 4,000 or something connections in the RAM, which is always very annoying. So yeah, documenting the build process there, so go and check me out if you want. So, is that it?
Yeah, bye.